Okay, good morning. This is a foldable that you can use for your practice, and it is Rules of Exponents, okay? And you can use it as a foldable. And so at the top here, I've gone ahead and given you a few definitions to make sure we understand what we're talking about. So that says 3b to the power of 2. And so in that instance, 3 would be a coefficient, b is the base, and 2 is the exponent. Okay, the first rule we're going to talk about is the product rule. To multiply when two bases are the same, you write the base and add the exponent. So here's a couple examples. If you want to multiply x to the power of 3 times x to the power of 2, well, the bases are both x, and so that would just be equal to x, and then you add the 3 plus the 2, and it would be x to the power of 5. Okay, if we had a coefficient out here, say we had 2x to the power of 3, and we'll change it up to, let's say, 3x to the power of 4. Okay, so we would multiply the coefficients together, so 2 times 3 is 6. And then when we multiply with common bases, we add the exponent. So 6, and this would be 3 plus 4. So our final answer would be 6x to the power of 7. All right, let's do an example with some numbers. Okay, so let's see. I have 3 squared times 3 to the power of 4. Okay, so we can still use the same rule. The bases are both 3. So that would be 3 to the power of 2 plus 4, or 3 to the power of 6. And I already did that on my calculator, and that is 729. Okay, so that is the product rule. Okay, the power rule says to raise a power to another power, it's sometimes called the expanded power rule. Okay, expanded power rule, write the base and multiply the exponents. So that would be something like x to the power of 4 raised to the power of 3. And so at this, we would multiply the 4 times the 3, and it would be x to the power of 12. Let me get a different color here. Okay, so another example might be 5 to the power of 3, and that is going to be raised to the power of 2. So here we would say that is 5 to the power of 6, and then you can use your calculator, and 5 to the power of 6 is 15,625. On ones like these where it's just numbers, you can use your calculator anyway. But let me give you an example where you might have a little trouble. So maybe we have something like, let's see, I have 5x to the power of 2, y to the power of 4, and then all of this being raised to the power of 2. So we have to use the expanded rule because that power of 2 is going to be applied to each term. The coefficient, so that would be 5 squared. It would be to the x, so that would be 2 times 2, which is 4. And then to the y, and that would be 4 times 2, which is 8. And then to write this in simplest terms, you do want to go ahead and square that 5. So 5 squared is 25. And we get 25x to the 4th, y to the 8th. Okay, let's see. I have one more example here where I just use x, y squared. And for that, it would simply be, there's an understood 1. Let me get a different color there. There's an understood 1 here and a 1 here. So when you go to expand that, you're just going to have x squared, y squared. Okay, so that is the power rule. Next, we have the quotient rule. To divide when two bases are the same, write the base, and then subtract the exponents. We're going to expand on this in a moment. But for now, let's just look at a couple examples. You could have x to the power of 5 over x to the power of 2. And so you would simply take the bases are the same, and this is 5 minus 2, and so that would equal x to the power of 3. Okay, another example with numbers. Say you have 10 to the power of 4 divided by 10 to the power of 2. So simply would be 10, 4 minus 2 are 10 squared, and you would want to simplify that to 100. Okay, and again, we'll expand on that one in just a moment, but that's good for now. Okay, the negative exponent rule. If a factor in the numerator or denominator is moved across the fraction bar, in other words, if it goes up or down, up to the numerator or down to the denominator, the sign of the exponent is changed. So there's some simple examples where we could have like, excuse me, let me get that back to the right spot. So we have x to the negative 2. So we can't have the negative exponent, so it just moves to the bottom, becomes 1 over x squared. Okay, so if you had 5 to the negative 2 power, that would be 1 over 5 squared, which would simply be 1 over 25. Okay, I might need a little extra space. You might want to write this somewhere else. I'm going to clear this off and give you a couple more examples which will help explain how this works. So I'm going to give you something like x to the 5th over x to the 6th. Okay, and so usually most people want to start in the numerator, okay, and so just say x to the 5 minus 6, and that's correct. Well, that becomes x to the negative 1. And so then you have to rewrite it as 1 over x. Okay, there's one example. What if we have something like, let's see, 4 to the 4th over 4 to the 6th. Okay, notice right now we're using all the same bases, so that's how the rule applies. So again, this could be 4 to the 4 minus 6. That's going to be 4 to the negative 2. So that would be 1 over 4 squared. And your final answer would be 1 over 16. Okay. So I think we'll do some other more difficult examples on the next video. So let me just finish the rules here. And then I'll do some examples for you on the work that you're going to turn in. So the zero exponent rule says that any base except 0 raised to the, that should say power, power of 0 is 1. So if you have x to 0, that's 1. If you have 5 to the 0 power, that's 1. If you have 125 to the power of 0, it's 1. The only exception is 0 itself. 0 raised to the power of 0 is undefined. Okay, so those are the rules. I'll leave this video and hopefully you can make yourself foldable with this information, and then I'm going to put a second video with some examples and then work that you do need to turn in. Thank you. Have a good day.